You may be hearing that people are talking about hurricane once, and then they're mentioning cyclones, and somebody is saying typhoons, and they all sound like they do the same thing. So what's the difference, you may be asking? Well, kids, they are actually the same processes, okay? As we said before, in warm waters in low latitudes, typically tropics, between the Tropic of Cancer and Tropic of Capricorn, you have warm waters, and if you put a little circulation in the atmosphere on it, it may begin to take up water vapor from evaporation and then condense it and release the heat and get stronger and stronger and stronger and start rotating more and more and get bigger and bigger, take up more energy from the ocean and produce winds that are really crazy strong enough to throw up roots and build, drag down bridges and pour tremendous amounts of rain, as we already talked about with Hurricane Harvey and so on. And this is a nice map that shows that there are tropical cyclones, as they are called, because they are born in the tropics. There are also cyclones that get born out of the tropics. They are called extratropical cyclones and so on. So you have warm waters, cyclones, warm waters, cyclones, warm waters, cyclones, warm water. Even in the southern hemisphere you have some cyclones. The number of cyclones and typhoons and hurricanes. Well, first of all, let's say what are cyclones, hurricanes and typhoons. Just by historical accident, even though they are all tropical cyclones, the name remain as cyclones in the Indian Ocean. They are called the typhoons over here, and sometimes they are called hurricanes or cyclones on this side as well, and they're called hurricanes on this side, and they're called cyclones around here. So they are the same thing, and they rotate in which direction? They're called cyclones because they rotate in the same direction as the planet does. If you curl your fingers around the Earth's rotation, it's going from west to east around its rotational axis, but the cyclone also has to look like it's going from west to east. So if you put an axis through the cyclone, it will go in a counterclockwise or an anti-clockwise direction in the northern hemisphere, but in the southern hemisphere it goes in a clockwise direction. Why is that? Well, Earth is floating in space, and if you look from the north it goes like this, and if you look from the south it goes like this. So you have slightly different directions, and you can think of it as a mathematical thing. So don't worry about it. If you want to remember, if you're listening from Australia or South America or South Africa, southern Africa and so on, Kenya here is straddling the equator, and people do some funny experiments with a bucket to show the water rotates in different directions as they step on this side of the equator and that side of the equator, and somebody says look in the bathtub or the sink which way the water goes, and so on and so forth. But those small things depend a lot on friction, something that happens between a surface and the water. But the cyclones are too large, they don't care about the friction, so they will go in the counterclockwise direction in the northern hemisphere and the clockwise direction in the southern hemisphere, which you can see here. So this is obviously a typhoon, and there are multiple typhoons here, a monstrous one here, and there is another one here. What do you see? The cloud bands are in this direction, which is the counterclockwise direction. What is this region? You can see here Alaska and Asia and the Philippines and so on. So this is the Pacific Ocean, where these are called typhoons, and this is the image of typhoon Chiba, I think. So I got this from the good people of Britannica, Encyclopedia Britannica. Thank you. And here is another image from the same source of something in the Atlantic Atlantic Ocean or the Gulf of Mexico. Here is the Atlantic Ocean. Here are some islands, Cuba and the Dominican Republic, and the Caribbean is somewhere down here. Florida is sticking out here. We talked about Alabama and Louisiana and Mississippi and so on. They all sit on this coast, with Florida on this side. Texas is over here. So this is a very, very warm water here, which means the ocean can keep on feeding the hurricane even after it's born in the tropics and keeps coming north, because the hurricane, as we said before, or cyclone or typhoon, takes the energy from the ocean. The ocean cools because the cyclone has sucked up all the energy. Then the cyclone moves to find new energy, so it keeps moving, right? So you can see that here there is a cyclone that is sitting here on warm Gulf of Mexico, and a lot of warm water here. You can see the sea surface temperatures in degrees centigrades, 29, 30 degrees, maybe here 31, 32, or even 35 degrees. And there is a cyclone going again counterclockwise, bands of rain, and you can see the scale here, how big it is. It is sucking in winds and water vapor from long distances as well, and you can see that here as well. You don't get a sense of the scale, but you can see this is about 1,000 kilometers at least, sometimes larger. Okay, so here is an image of twin cyclones in the Indian Ocean. So here is the peninsulas of Thailand and Singapore and Malaysia and Indonesia over here, India and Sri Lanka over here. The equator is somewhere over here, and you can see there is a clockwise rotating cyclone south of the equator, just as we said, and there is a counterclockwise rotating cyclone in the Bay of Bengal. So this is one nice example of how cyclones were being formed on the south of the equator and the north of the equator at the same time. They call the twin cyclones. Let's now move to Hurricane Sandy that we mentioned here. It was born somewhere here in the warm waters down in the tropics, and then it started wandering around, and the scales here are how strong it is and where it went and so on. But you can see how the hurricane moves and gets stronger and hits land, and can get weaker because it's not getting the energy from the ocean, or the water evaporation is not happening anymore, and so on. So it was going this way, and everybody thought it will happily go off into the ocean and disappear, because that's what cyclones do once they get on the cold waters or on land. But for some reason it took a sharp left and crashed into New York. Here is New York City and then New Jersey, and created massive damages. And you can see some image of this kind of a Sandy, which was so big it had feeding bands, the feeder bands that were all over the place, and it was obviously coming with very strong winds. Depending on how strong the winds are, they measure the strength of the cyclone or the category of the cyclones. Category 1 has got some wind speeds, I won't mention them, you can go look them up. Category 2 is stronger, 3 is stronger, 4 is devastating, 5 is deadly strong. And you can see it, a massive tree with all its roots, it's just knocked it off like a domino or like a little stick. So you can see how strong it is, and it pulled down the wires and can't cut off power. These houses seem lucky, they are not damaged much. They can crash into the house, and gas lines can explode, and you can have fires, or you can have water here like coming all the way to the door, and the car is just sitting in the water. And maybe this is a little church here that's above the water. But because the rain bands were so large, it also hit the mountains here in West Virginia and produced massive amount of snow. So it was pouring buckets and meters of or feet of rain over New York and New Jersey, but it was throwing feet of snow in other parts at the same time, because it happened in late fall. Okay, so cyclones, typhoons and hurricanes, they are the same meteorological processes born over the warm water, rotating counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. They keep getting stronger and crash into land. Sometimes they stay on the ocean and dissipate away. as they get on the cold water, because there is not much energy coming from the cold water. Evaporation happens much more on warm waters, like when you are hot and you are sweating, because your body is trying to get rid of the heat by producing sweat, which will evaporate and cool your body. So just remember these things. And Sandy was a good lesson for many to realize that maybe you are not so immune from cyclones, and as the warming happens, cyclones may come into higher latitudes because they like warm waters. Okay, so we'll come back and talk about another very important topic, the sea level rise. We already said as global warming happens, greenhouse gases increase, energy trapped, and we are melting glaciers. Glaciers are built by moving water from the ocean onto land, and when it melts, puts that water back into the ocean, and the ocean begins to rise. And of course we are warming the ocean and expanding it as well, because warm waters have lower density, larger volume as well. So sea level is rising because of warming oceans, melting glaciers, and there are also changes in rivers coming in, salinity or salt content of the water, rainfall on the oceans, and so on. So we will discuss. We mentioned already sea level is rising. Other thing you have to remember is when the cyclone is coming onto land, it is pulling all that ocean behind it, and if sea level rises, it will bring more of the ocean water. It's called flooding and inundation, storm surge, and so on. So it will pull all that water. So sea level rises by this much, and you may get much more water coming into land because of cyclone is acting on a rising sea level. So the key question is, if globally average sea level is rising, is it rising the same way everywhere like a bathtub filling up? You can imagine not, because there are winds which are moving the waters around, there are ocean currents, and so on and so forth. So sea level rises somewhere, can fall somewhere, but we have to be careful about where it is rising, how fast it is rising, and how fast will it rise in the future, and so on. So come back and talk about sea level rise in the next podcast, kids.